Hello, 8th graders. In lesson 4 here in unit 6, we're going to be fitting a line to data and looking at the trends on the scatter plot. In your first problem, read the instructions, use the scatter plot to help you, and remember to explain your reasoning. Start again when you're ready. If I'm looking at a vehicle that has a weight of 1,750 pounds, according to the scatter plot, its fuel efficiency is going to be closer to that 22 mile per gallon range. It's not looking like it's going to be up here near 28. In the next activity with Shine Bright, we're going to be looking at some real life data with the weight of diamonds and their price. One thing to note is that the weight of diamonds is measured in carats, and the bigger the diamond, the more expensive it's going to be. The line on this scatter plot is the line of this equation right here. This is the model of the data, meaning the line that fits the data the best, and we can use the model to predict the price of a diamond of any weight. We're going to do number 1 together here. 2 diamonds that both weigh 1.5 carats have different prices. What are their prices? So I'm first going to look at the table. Here's my 2 diamonds that have a weight of 1.5 carats. Here's the actual prices for those diamonds. The predicted price is coming from the equation for the model right there. This is not asking about predicted price, it's only asking about actual price. So we see those actual prices right there in the table. How can we see them in the graph? Well, we're looking for the 2 points that have a weight of 1.5 carats, and it's really hard to get their actual prices from the graph, but you can still get an estimate. Number 2 now is referring to the model and the predicted price. So if your diamond is 1.5 carats, if we plug 1.5 into our equation for x, I would have y equals this times 1.5 minus this. And if we use a calculator to evaluate that, we would end up with that price of $7,189. So that's using the model to make a prediction. And how do we see that on the graph? Well, now we're looking for the line. So at 1.5 for weight, we're looking at what would the line tell us it would be. We can see it's a little over 7,000. We get the more exact price using the equation. Number 3 has a diamond with a weight of 1.9, and it's asking what does the model predict. So I plugged 1.9 into my equation, and the model is going to predict that this is the cost. How does that compare to the actual price? I'm going to go to the table now. Here's the predicted price from the model, the equation. Here's the actual price. They're pretty close. So the model made a good prediction there. The model makes a really good prediction for this diamond right here. I can tell on the graph because the point is pretty much right on the line. And over here in the table, the actual price and the predicted price are only different by $11. That's really close. The model did not make a good prediction for this diamond right here. It is pretty far away from the line if I go straight up. And I can see that on the table as well because I can see that my price and my actual price are different by way over $1,000. In activity 3, we're looking at measurements of feet. Answer questions 1, 2, and 3, and start again when you're ready. Using the x-axis to look at length, here's my longest foot, here's my shortest foot. You can see the estimates I made for those over here. And here's my widest foot, again, same one up here, and my narrowest foot down here. You probably noticed that this point down here seems weird compared to the rest of them. We call this, when we see a point that's far away from everything else, we call that an outlier. I want you to write that down and label that. In lesson 5, we're going to be continuing to look at trend lines, and now we're looking at associations as well. As always, you can come up with a reason for each of these why they don't belong. For this one, it's the only one that has a positive slope on the model. This is the only one that has a line with a negative slope. This one doesn't have a line, and this is the only one that crosses the x-axis. Now we're going to be working on drawing your lines of best fit. I do want you to have a piece of pasta and a straight edge for this The pasta is just going to help you visualize where the line would fit best. I'm going to use the ruler on the screen here, and I'll show you just some guidelines to use when drawing your line of best fit. So first, we want it to be about splitting the data in half, meaning about half the points above the line, half the points below the line. But the most important thing is that you are showing the general trend of the data. So that one ended up working out pretty well. If I had something, I'll go over to this one, that maybe ended up a little too low, then I would want to move my line and try it again. So draw the best line of best fit that you can, eyeballing and trying to get the best trend of the data. Go ahead. On the left, I drew what I think would be a good line of best fit. Again, we're just eyeballing it here, putting it where you think. Now, a common mistake people will start to make is they might draw a line that looks something like this. And they'll say, well, I split the data in half. Well, yeah, you did, but it's not showing the best trend in the data. This one would have a positive slope going this way, showing the best trend. I want you to turn to your lesson synthesis in lesson 5, and this scatter plot is there, and I just want you to label a few things as part of your notes. So this entire graph we would call a scatter plot. This line that we have here, we've been using a few different words for this. We first heard it called the model, and that's if we wrote an equation for it that looked like y equals mx plus b. And we can use that model then to make some predictions. We will also hear it called a trend line. And that's what you were just drawing to try to get, to show the best trend in the data. But you may also hear it called the line of best fit. Any of those terms work for that line. So get used to using all three and seeing them in problems.